Now it's on.
Hey guys, welcome to math class. Here, we're about to do a little math. It's gonna be fun. Hope y'all enjoy your time. Not in class, but we're in class. Basketball game tonight at 7 Button Road Park. Everybody show
Okay,
out.
we got 0 viewers. Thanks for everyone showing out today. 3.1 podcast. It's about to be LIT. Let's do this thing.
Right on. There we go. For all my YouTube followers, thank you so much for showing up here. Hopefully this helps us out. We're going to get rolling with some exponential growth and decay. So let's get this underway, all right? Again, it's a part of a class. You're going to hear some questions here, which is absolutely awesome, fun. And we'll go from there, all right? Before we get started, though, we're going to have a little bit of a game. We have two different logos here. So if you know it, raise your hand and we'll go from there. So this one on the left side, which one's that?
Oh, I know the
Left side? Left side.
Tag warrior.
Yeah, that's exactly right. Nicely done. One on the right side? Does a lady know this one? Isabel, do you know? No? Ian, what is it?
No! ESPN!
Nicely done. Nicely done. Okay, so as we continue, okay, we're gonna as we start, we've already introduced kind of exponential decay and growth in class, so we've kind of already introduced that. So we're gonna get right straight to kind of go there, right? So first thing is remember that this is kind of an exponential graph over this side. This have a horizontal is at y equals 0. Okay. Now that's going to adjust as we have transformations. We'll talk just as a review. All right, just as a review, be the domain of this function. And this would keep going, right? Well, remember, domain is left to right, correct?
Oh.
Yep, negative infinity to infinity. What about the range there, Brandon? Range is what?
0 to
John? Infinity. Very good. Okay, we got that. What about, we're going through this, I get it. What's the interval of decreasing? There isn't one, right? There isn't one.
None.
Yep, there's none. And Jacob, what would be the interval of increasing?
That'd be negative infinity to infinity.
Yep, negative infinity to infinity. Good. A lady help me asymptote here. What is it traditionally? Yeah, y equals 0, right? Good. For this one, I know it's hard to see, but it is y equals 0. Good. What is the end behavior we're going to hold off on? What about intercepts? Are there any intercepts there? There's no x-intercepts. What about y? Yeah, there's one right in here. You can't really see it, but we'll say it's at 1. All right? So again, just kind of where we're at. Wanted to make sure we went through it. Now, the big part with the activity that we're doing today, this is the part that we're going to hit on to where you don't have to do the ones on the homework, and we'll show you that in a little bit. But what this is we call this one-to-one. What one-to-one means? It's actually really true. Nicely done, Jacob. Yeah, we're trying to get both of these equal to 0 or equal to each other, all right? So we can cancel out. Now, with 2, right, this is 2 to the what power? First, right? We're just going to put that here. Now, what about 8? How can I get that to where it has a base? Okay, that's a good thought, but I can't divide by 4 because of the exponent here.
You have to make it a negative.
Okay, a negative, what does negative power do? Like, what's 2 to the negative first do? True, it would be to the left, right? It flips. Well, it was on top, now it goes to the bottom, right?
Yeah.
So what if I had 8? What could I do with 8 to get it to the second? 2. 3, right? Does that make sense? So 2 to the third power is 8. What I can do is say, okay, 2 to the third, and then also then include the 2 plus x. Y'all see that? Is that coming up on me? Perfect. Okay. So what do I do with the power to power? Good. So we have 2 to the 6 plus 3x. Good. Not 2. My fault. And that equals then 2. Sorry, I don't know why that's there. So to the first. So now what can I do now that we have the same basis?
Make
The x, -2.
Make the powers equal to each other.
Powers. Now, since the bases are equal to each other, we could actually cancel. So now we have 6 plus 3x equal to 1. Okay? We'll do another one of these in a second. But then you could just solve for x. So what would I do to solve for x? Subtract 6, divide by 3. Holla at me. Nicely done. So 3x equals -5x. All right, or -5, I'm sorry. I'm a little off my game. Sorry. For those followers in Sweden, I apologize. So x is equal to then -5/3. Are y'all good with that? Y'all good with that? Okay. All right, let's do another one just to make sure that we are Gucci here. Let's take a look at this one, okay? What would I do with this one? What would be the like basis, Jacob?
4.
Good, so we'll keep the one on the left, right?
Yep.
And the one on the right, how could I make 16 with a base of 4?
Root. Oh, wait. 4.
You say square root, it's really 4, right? Okay, so 4 squared, and then that's to the x plus 1. What do I do here? Distribute. So we get 2x plus 2, right? So what do I do then to the 4's?
Cancel them.
Cancel party. Nicely done. And then we can from there. So 3x plus 5 is equal to 2x plus 2. Does anyone know the answer to that? Yeah.
-3.
Nicely done. Good, Nate. And then we would go, yeah, Brady.
Could you do it the other way, like multiply 4 by or square 4 to get 16 instead of doing something to 16?
Yeah, here's the problem though. If I put like in place of this here, if I put 4 squared in for that base of 4, right? Is 4 squared equal to 4? No, but if I go to 16 and put 4 squared in for 16, I could do that. Now, as you're talking, Brady, that's actually a great point. I could, with this 4, do 4 to the 1/2. Or, I'm sorry, 16 to the 1/2, right? What's 16 to the 1/2 power really doing? Square root of it, right? The square root of 16 would be 4, and so you could do it that way. For me, I find it easier if I do it the opposite way. Where if I take, like, for instance, over here, right? If I took this one, what would I do to get bases alike? 36 to what? 6 squared. Does that make sense? It's a little easier, I find, than trying to do it the opposite way. Does that make sense? It's actually a great question. Does anyone have questions on that? All right, we are going to come back to this. This is a lot of what, this is the main thing that we were kind of just going to talk about as far as what we're going to do on the side. Hit on a couple other things. I've got 2 more kind of slides here, and then I might do one more thing just to put it on the podcast and be done. All right, so really quick, if I have 3 to the x, all right, we're going to have a lot of participation here. If I have this right here, and we'll get to this, what would be a reflection over the x-axis? You could also write this way, by the way. Y equals 3 to the x power 2, okay? Either way, it's a function or an equation on that. What would I do to give it a reflection? Go ahead, Josh. What would we make a negative? Good. So we have -3 to the x power, right? So this is something too, just kind of want to put on the side. So y equals -3 to the x would reflect it over the x-axis. So here's the picture. I'm going to do a rough sketch here. We have y equals 0, right? So if we normally go this way, right? Reflection over the y-axis would look like what?
Yeah.
Something like that, right? And what's in red? Okay, what's reflection over the, I'm sorry, I messed up on, should it be reflection over the x-axis? So it should be
Yeah, down there.
underneath, right? Now, what I did was the red one, this would be the red one right here in red. Okay, what would be reflection over the y-axis? What would I have to do? Negative power, good. Bart's on a roll there, good. So we have y equals 3 to the negative x, right? So that's how I would get to what's in red. Y'all, I confuse you. Are y'all good on that?
Feel good.
So the blue one is what's up here, and the red one is reflected over the y-axis there, okay? Here's the way I remember it. Y-axis reflection, the x is negative. If it's the x-axis, then the negative is with the 3. All right, so that's just a heads up there. So what if I took the blue one, and I'm going to back up here. Let's do this. Get that there. What would I do to shift it left and right? What could I do on that? Add what?
Just any number.
Where?
The 2 on the end.
On the end right here?
Yeah.
Does anyone want to change that? Shift that around, Josh?
Does that move it up and down?
Good. Yeah, this would actually move it up and down. This would be here, right? So if you traditionally had a horizontal asymptote right here, right? What would happen to that graph? If it's on the side, right? So question, where would be the new horizontal asymptote if I moved it up to?
Outside of the parentheses.
Say that again. Say it would be 2, right? So what would traditionally be y equals would make it y equals 2.
2.
Y'all see that? Can we go over that again?
Yes.
Okay. So this is traditionally where we're at, right? Y equals 0. Because of this 2 on the outside, what does this graph do? Well, it up 2 spots, right? What's up, Bo? Thanks, man. Do you have an appointment today?
Show up
Yeah.
whenever. Oh yeah, I will.
Hey, we're live. We don't need that.
That's right. No dissing
We are
on
YouTube
podcasts.
live right now.
We are live. We have all our followers out there. So because of this, right, you see that horizontal, right? So what was that 0 turns up and goes up 2, all right? Y'all good?
Yeah.
What if this had -3? What would be the new horizontal?
Down 3.
Down 3, right? So it'd be at y equals -3. So that's just kind of telling you the vertical shift, the number on the outside tells me where the horizontal is going to be. All right, you're good, say uh-huh. Nicely done. Very good. Okay. All right, so this is up and down. We'll just keep it right here, x plus 2 on the outside. So what's the difference? We didn't do left and right. What would be left and right transformations with this?
Put that in parentheses and put in another number outside of the parentheses.
Like this and then another number outside? Okay, not quite. That's a good thought, though. Does anyone know? Anyone know? What about with the exponent? What if it be -1? All right, where would that go? Good. We would then, again, where's the horizontal with that one? With this one right here? Still at 0, right? All we're doing now is shifting it from where it traditionally is. We're shifting it. Okay? Go ahead, Josh.
But wouldn't that, like, if you were to actually just plug it in, wouldn't that just make it?
Yeah, do this. Let's graph this one first, 3 to the x, okay? By just using a t-chart, we'll just talk it out. If I plugged in 0 in for x, what would I get out for y? 1, right? So wouldn't you agree that what if I plugged in if I did 3 to the second, what would I get here? 9, right? Okay, so we're going to go up 9. So do you see how this graph is the traditional one, Josh? Okay, and I know it's a little off, but you get the idea there. What if we did 3 to the x minus 1? I plugged in same numbers. Plug in 0, okay? What's 0 minus 1? What's 3 to the negative 1/3, right? Do you need me to show you that, or are you all good? Because you flip it with the negative x. When I plug in 0, you're going to get 1/3, which is kind of lower. What if I plug in 2? What would I get? Okay, 1, which is 3 to the first would be what? 3, right? So we go here, go up 3, right here. So the graph, again, it's going to shift everywhere it's at. It's going to shift to the right 1. Lord willing, if it comes up, we'll be good. So, sorry, Josh. But yeah, you see what I'm saying there? That's kind of what it's doing on that side. I just got knocked off. Hold on just a second. We did. I'm still live, though. I'm still good over here.
Yeah.
See if this will go.
ISO.
I will ISO you every day.
Okay. With that, here's what I'm okay. I'll do real just together to tell me the type of transformation that's occurring. We'll do that real quick. Again, we'll go to one more slide kind of at the end, and we'll show you kind of how to do that here. This one right here is kind of the big picture with graphing, all right? So as we talk through it, tell us what's happening transformation-wise, and we'll probably graph one of them just to make sure we're good, all right? So number 7, is there any transformations on that? No, okay, so no transformations. What about number 9? Where's our transformation on number 9? What's negative, x or the outside? X, so we think opposite, so it's a reflection over the what? Y, good. So just to give you the picture, what normally would look like this, if it's a reflection over the Y, would be where? Yep, opposite way. Good job, Cam. Good work there. Okay, so that's kind of where we're at. What about number 11? What would the transformation look like on number 11?
Yeah, because X.
Okay, so it's left and right or right?
Right.
Opposite, right? This would go right to, okay? Right to. So what traditionally would be at the blue spot, every one of those points would move to the right to, okay? Sweet. Okay, so do this one, and then I'm going to have you graph one here. Look at 13. What transformations are occurring on 13?
Reflection and
Good. So this is a reflection over
the y-axis
good of the y-axis. Good. And what about -3?
goes down 3.
Goes down 3. Good.
Same for
Okay on that? Yeah. Is everyone good? John, may I ask you a question then? On this one, vertical shift is down 3, right? Where would the horizontal traditionally at 0? Very good. But because of the fact that we have this transformation, where would it go down to? Very good. You see that? Does everyone see that?
It feels like it should be harder.
What is it? Yeah, it should be. Yeah, I hear it. What should be at 0 is now going down to. Okay, that makes sense. All right. Let's look. Let's do this. I want you to really quick on number 13. I want you to graph 13 really fast. All right. You can do 2 things. You already have the transformations. You could graph 5 to the x and then transform it, or you could actually plug into a T-chart and then go from there, all right? I'll kind of come around and just make sure you're good. If you need some graph paper, I have some on the side you can get to. Then we're going to get into our calculator real quick and then go from there, all right?
That's our. We got our reflection, which is going to be down. No, the y-axis. No. I don't know. I haven't thought about it. I'm sorry. Yeah, you're taking it. It's either you.
All right, hold up. If you're on YouTube right now, hold up just for a second. We're going to actually look at how to graph this and go from there. So while they're doing that, one of the things that I wanted to just kind of mention to you is we can graph 5 to the x equals, and we could do that. I can't see you there. We could do that plugging in value. So again, this is traditionally y equals 0, right? We could plug in 0. When I plug in 0, I get 1, right? 1, I get 5. And so as you can see, this graph, if I go down, there you go.
I've drawn the graph.
Right there. It's traditionally what's in black, right? With x and -3, we're transforming it. And so you do this either by a T-chart or by looking at transformations. That would be awesome. All right.
Are we still doing the motion?
Yeah, we will. I'm going to get to that one in a second.
I swear. I swear.
Chad, you're Chad, you touched on the
That's what you're doing. If I do 5 to the negative x, the negative
It's mine.
on the x flexed over the y.
I was taught it.
So then what you
Yeah,
do
but on
is
the
then
for the 2 weeks
this way.
that he's gone, exposed. Yeah.
That makes
The
sense?
2 games that he's gone at my team.
Hey, as y'all are doing this, if you need some help on something, one of the things that I have seen is, we were talking over transformations, I just sketched it. But when I say graph it on the test or on the homework or whatnot, please make sure you have at least a couple points so you know how to transform it, okay? So like this is 5 to the x power, right? Josh, what would be the horizontal asymptote? And so you could bring her down, right? Bring her down. I don't know. I was just, yeah, I don't know what I was doing. So then down, what traditionally, each of these points will go down 3, right? But when I go down 3, 1, 2, 3, except it's not going to rise to the right, it's going to rise where? Because of the negative x, it should traditionally, right? But the negative x does what? Okay, yeah, it's reflection over the what axis? The y. So what traditionally would go this way will now go this way. All right, if you're confused on that, just try to plug in a point. So let's say we plug in -1, okay? So if we go left 1, -1 would turn into what? What would turn the first?
5.
Yep, -3 is 2, right? So we could go -1 down to where?
-2.
-2, exactly. So as I go left 1 this way, what I can do now is I'm going to rise here. Y'all see that? Are y'all good on that? I know it's not like extremely exciting. The other stuff we're going to do a little bit later will be transformations on there. You could do it by T-chart, or you could graph the original and then transform it off that, depending on what floats. If I'm on a test, I probably do both. All right, probably would do both. And I would even plug in further and kind of get that idea. Because once I go -2, it actually should be a little bit higher. Awesome. Bo?
Do we have to do a T-chart if we know the road? So,
No. So what I did was on the podcast while y'all were working, I just kind of just set it out there. A lot of times, if you just graph 5 to the x equals 0 first, I would graph that using a T-chart,
okay.
or at least finding. Then afterwards, if I say points are going down 3, it's only going down 3, you're reflecting over axis. That's going to be a little tougher. So if I'm you, what I would do is when I write this down, I might do a T-chart for this one, but one like number 11 or one like number 12 or something like that might not. Okay. All right, perfect. All right, do this. Get your calculator out. I want to get this on the pot real quick and then go from there. This one says use a graphing calculator to graph the exponential function. All right, what we'll do is this. We'll do 3 to the negative absolute value of x. We'll do that one. Okay. All right, do this really quick. Go from there. Oh, yeah, Brandon also asked me, what was the logo? Don't yell it out. Does anyone know the logo of this one?
Where?
I know it.
Right here.
I don't know.
Yes, I did.
Brandon, what is it?
Sprite.
Nicely done.
Oh, that one.
Hey, snagged it. Like it. Does anyone know the top right?
I know that one.
Here, what is it? Sprint. Nicely done. Nicely done. Okay, so do this on your calculator. Y equals, put in 3 to the negative absolute value of x. Do y'all know how to do absolute value? No? Okay. Just get that right. And what's up?
Yeah.
Okay, let's go here. Coming in, little guest appear. Okay, so let's do 3. And when we do to the, right, you know how to do caret, right? Okay, so we're going to do caret, parentheses, and then we're going to go absolute value. Now, when we do this, we can go to the catalog right here, and be at the top, you can just click enter the ABS, the abs, right? You didn't know your calculator had abs.
6-pack.
6-pack, yeah. If you press enter, what you'll do, you'll see that it's got like, it's either there or it'll have ABS, which is the same thing. I'm going to go to negative x, and then go from there, okay? Second, does anyone have questions on how to play that? That? Yeah. Now, here's where I wanted to show you, and this is the only thing, just so that we're all clear. When we graph it, or whatnot, look something like this. To graph it yourself, one of the ways that you can also graph you get to here, because I'm guessing we're okay. If you go to your table, okay, so graph, you can actually have the table of values that are there. So as you graph this, you could even put like 0, 1, right? 1, 3. So if I said, take it from your calculator and actually put it on a graph, trying to like graph it and make it a T-chart, you could do that. But in essence, this is your T-chart. Y'all understand that? So if you ever like have a calculator and you can use that, that's a way to use that and kind of go from there, okay? Does anyone have questions off of this? Is anyone able? Is everyone good with that? Okay. All right. Very good. Okay, so with that being said, I want to go over one other thing, and this is kind of the little bit better stuff. Include all this podcast so everyone's missing can access it, and then we'll go to something else in class, right? So this is not something that's new. You've had this before. I'm going to make sure that this is not on me here. There we go. Let's see. Okay. All right, so let me hit on this quick. I'm not going to go into like much detail because I know you already know this, all right? So let me do this. Let's just give tickets to people who know this. The one on the top left, we call that compound interest, right? Does anyone know what compound interest is used for, or like what this equation is used for, Brandon? Money in accounts,
Bank
okay.
accounts.
Could be bank accounts, could be an investment. It also could be, we talked about the negative side of it, what? Cars, yep, or student loan interest, yeah, and that could be positive or negative, right? Very good. All right, is everyone good on that?
Yeah.
Now, and it went off behind me. What did I hear? What does P stand for in this equation? Principal, right? Exactly. What's principal stand for? Like, what is principal? Good. It's the base amount that I'm either borrowing or it's the base amount of what I'm investing, right? Awesome. And again, we're going to go into more detail. I wanted to get this on the podcast as well because I know a lot of you already know that. What is R for? Good. One problem that I see when we plug this in is 3%. A lot of times people put in 3. Decimal point, right? What about N? What's N? Very good. So give me an example of what that would look like. Yeah, so if I say compounded monthly, that means that what would I plug in for N? I plug in 12, right? That's important because when you go to a bank and it says one may have a higher than the other, but one may compound in different ways. So it might be a better option for you to do another one compared to the one that maybe has the higher rate there. Okay, so that's just a heads up there. T stands for years, right? So T is just the amount of years that I plug in for. We're going to do more problems off this, but I want to make sure I hit on it. As far as continuously compounding, what is this? What does the E stand for? Okay, that's something different. Good thought. Yeah, it's something in our calculator, right? It literally is a problem, or it's what's used for exponential equations, or it's a specific number that is associated with compounded, what we call compounded continuously. Right? R is still the rate, T is still the years, P is still the amount that we initially invested. All right. So let me give you a quick one, and let's see if we could solve this one and go from there. Oh yeah, what was the logo?
Iron Man.
Nicely done. Good job.
The triathlons.
I was trying to see this one on the. Does anyone know this?
I know that one. I know.
Got you one on this one?
I haven't answered the
You've answered the logo. Bo, do you know?
Looks like a crown.
I got it.
Done. Staples. Yes. Staples. See it?
What is that?
It's the L.
I don't like.
Yeah.
Why is the hell
Say that again. It's the. It only has part of the logo. You know what I'm saying? Okay, so let's do this, and I know it's really, really simple. Okay. Oh, yeah, forgot about the logo as well. We'll do that before we get to the problem, our last problem of the day. All right? Ladies, do y'all know? Those are tough. Caleb, do you know? No? Who has not answered one? Josh, you have not, have you? What is this? It said 2012, I think. But it is London. Nicely done. Yeah, nicely done. All right, so let's do this one. Okay, so, and again, I'm not trying to insult your intelligence. I want to make sure I get this on here because later on today we're going to look at just how the project's going to impact us going forward. All right, but I want to make sure I do one of these before we go from there. All right. All right, $25,000 to invest for the long. Let's do this. Casey, can you tell me what 25,000 would go into in terms of my equation here? Nicely done. Yeah, that's my initial amount, right? 25,000. Good. So we're going to plug 25,000 in P. Now, what else do we know? And what do I put in? 8.6, right? 0.086, right? Okay, because that's the rate, right? We got to put it as a decimal. What is N?
4.
Why? Good, because it's quarterly, we're going to put 4 in for N, right? Then it asks for, then it kind of just holds it right here, right? Now, here's the question I have, and this is why I want to just throw, because on the project that we're going to do, you're going to notice that, just side note real quick, okay? We do. But before I get to this part, I wanted to hit on this. How many of you are going to go into some sort of business? You think, or it's a possibility? Okay. How many of you are going to invest something at some point in your lifetime? Okay. Right now. Okay. I'm going to tell you right now that the problems that we're going to look at, both this one right here and the ones later on, will positively impact you moving forward. All right. So really, here's the thing. If I did not give you this in terms of years, okay, how could this equation benefit the business? So given just the information I've been given, without giving the years, how could that impact me, or how could I use this?
Predictions.
Good, predictions, right? Because if you don't know where to graph this, what type of graph would an exponential, right? Because the variable is in the exponent, all right? Are y'all good with that? All right, we're almost done. I appreciate your patience here. I know this is different with the podcast. We're going to break it up here in a second. But let's say that, again, I would say, all right, Brandon, now after 50 years, how much will you own or have? Well, at this point, you could put 50 in for T, right? Now, the only other thing that I will say is this. Make sure you do PEMDAS, right? My daughter's middle name, PEMDAS. Make sure that you go forward with that, all right? It is, yes.
No, it's not.
Emmeline PEMDAS Johnson.
No, it's not.
No way.
So what we'll do now is on the inside, we'll actually divide this out first, right? So do 0.086 divided by 4, and then just add 1 for me. Okay. What's on the inside?
Times 0.02. Yeah.
Okay, and then
Yeah.
0.285.
215.
Okay. At this point, what would we do? 4 times 50 we know is 100, right? Or 200, my fault. Wow, good night. What will I do next? Once I get this. Me too, I confused myself. What would I do next to simplify this? To the power, right? Got the power, all right? So we do 1.0215 to the 200.
How many decimals?
We'll do it to the second decimal now.
70.42.
Good, and before we simplify that, the second decimal though, let's multiply that by 25,000 to get our ultimate answer of 70. Oh, I'm sorry. Hold up. 700, what was it again? And then how many cents? Do we have anything on that? No cents? Excellent. Okay, so again, as we move forward, you're gonna realize this, okay? And more of the fun conversations about money and stuff, I've got planned for today into Friday. But here's the deal. This is powerful, okay? All right. If you haven't got a look at it, all right? Here's the thing. Being a millionaire is easier than what you think. Okay? Being a millionaire, well, kind of, but maybe not even. Being a millionaire is possible. And I'm not just saying from your parents, if your parents are at that capacity. I'm saying for you personally, for me, being a teacher, I know you think we make a lot, okay? Which we do, yeah. But it doesn't matter necessarily how much you make as much as how much you are saving, all right? We're going to look into this a little bit later, and we'll have some fun with the calculator later on. But I wanted to make sure I hit on that going forward, all right? Hey, for those of you on my podcast that are showing up, and
Give a round of applause, guys.
I do, thank you. A round of applause. Sure, okay. Hey, have a great day, and we'll talk to you later on in class. Bye.